Hello, friends. Tangential and normal components of acceleration. That's what we're going to discuss currently. And we're going to introduce what's called the TNB frame. T being our tangential unit vector, our N, our principal normal unit vector, and then B, we're going to introduce in this section a binormal unit vector. So T, let's think about what that tangential unit vector represents. And it means forward motion, right? Remember, this is the unit vector from velocity. So it's showing us the direction which we are going. Whereas that normal unit vector, that represents the turn of the path. That helps us understand the curvature better. So the tendency of your motion to twist out of this plane, which is created by that T and N vector, that twisting that may occur as something, spins through space. That is going to be perpendicular to those planes or to those vectors. And that's what's going to be our binormal vector, B. B is the binormal or the unit binormal vector. And this is going to be useful for our twisting and our turning to see how something is rotating in space. B is perpendicular to both our T vector and our N vector. And what we are going to define or identify is that B is going to be equal to T cross N. So finding the cross product of those two vectors is going to give me this binormal unit vector. The TNB frame, as we're going to discuss here, is created by these three mutually orthogonal vectors which are traveling with the motion. So you can see we have our tangential unit vector following the path of the motion. We have our normal vector, and that shoots into the curve. And that's telling us about how this curve is turning, the turn of the path, and helps us with the curvature. So we have this new piece here. This is B, mutually orthogonal to both of those other two vectors. They're all running down these sides of this cube, this invisible cube in space, oriented with a corner at that point P. But this binormal unit vector, this is helping us. It's going to let us know how this point may be turning or twisting, I should say, in space. So just to redefine a few pieces that we already know, remember that our T vector is equal to the V vector divided by its magnitude. The curvature K, or kappa, is the magnitude of the velocity vector times the derivative of the unit tangent vector's magnitude. And then our normal vector, our unit normal vector, is that derivative of the tangent vector, again, divided by that magnitude to make it a unit vector. So now we've introduced this one other piece, and in that, this is that the B vector is T cross N. One thing you do want to make sure you pay attention to is that the order is important when you're dealing with a cross product. So now let's talk more about this TNB frame. So what we were just talking about with this Tn and B, tangential, normal, and binormal all unit vectors, the TNB frame was discovered or defined by French mathematician Jean-Frédéric Frenet. And so again, we just want to make sure we understand what this looks like. So here's my particle moving through space. It makes sense that the tangential normal unit vector is moving along with the particle. The normal unit vector is perpendicular to the tangential vector in the same plane, pointing in towards the direction of the curve, or the concave portion of the curve. And then this binormal unit vector is orthogonal to both of these. And this is kind of describing that vertical motion or the twist that may occur. So the three of these together, they are really significant when we start calculating paths of particles moving through space. So I hope that helps you to gain a better understanding of what these three vectors are. In the next video, we're going to talk about the tangential and normal components of acceleration. So we're going to leave out the binormal for a little bit. And then when we get to talking about torsion, it's going to come back into play. So that's all for this video. Please email me if you have any questions or you find any errors.